Welcome back, gangies. We're back once again. I'm tired out of my mind. I literally cannot see straight. My vision is blurring in and out. So either I'm exceedingly tired or the clock is ticking. Fortunately, I'm indifferent to both because you know what this means? It means we must continue nonetheless. So that's where we're at. We might do a shorter session than usual today. Just cause, yeah, I'm like dummy tired. And it's strange because the tiredness is crazy. I think my sleep has been being interrupted, so I feel like I've been interrupted mid-REM sleep multiple times. So now I'm just like in this really weird state. So that's where we're at. But that being the case, we're gonna do a shorter session today. And I think we're going to do a shorter session as always on Fridays just because we're a little busy. And then we'll see where we get to. But yeah, so we're going to do probably like 25 minutes today. Nothing too crazy. Yeah, we haven't had to recover like this in a while. But I actually think this time it has almost nothing to do with the schedule or what we were doing. I think my sleep is being interrupted. My cat wakes me up in the middle of the night very frequently. So that is kind of an issue. It's particularly been this last week. So yeah, my brain is absolutely fried. I can barely stare at this screen. Hopefully things get better. I've been looking a lot into Terraform. I'm doing a lot of reading, a lot of watching of guides about RDS and so on. So soon we will understand everything there is to know about AWS. And then from that point on, Jeff Bezos will submit all of his assets and shares for the company to us. And then from there, we can pretty much start making some changes. So hopefully that's what happens. But I have a call with Elon later to figure out that stuff. So we shall see. That being the case, we do have some problems to do. And we did a bunch of problems yesterday. I think it was mostly check if it's... Okay, we did check if n and double exists. Some pretty simple problems, and so we're just gonna jump into it today and see how we do. So we're gonna set it for 25 and see how it goes. So we're given an integer array nums and an integer k. In one operation, we're given an integer array nums and an integer k. Integer array nums and an integer k. Integer array nums and an integer k. In one operation, you can choose any index I, where I is within the length of the array, and change num sub I to num sub I plus x, where x is an integer from the range negative k to k. You can apply this operation at most once for each index I. The score, so we have a number k which we can apply to any index between the range negative k to k, and we can do it once for every index. The score of nums is the difference between the maximum and the minimum elements in nums. Return the minimum score of nums after applying the mentioned operation at most once for each index in it. The score of nums is the difference between the maximum and the minimum. Return the minimum score of nums after applying the mentioned operation. So the minimum score is always created by the distance between the largest number in nums and the smallest number in nums. Oh man, my brain is fried and we have a problem we actually have to think about. And has a lot of dislikes too. The problem description isn't great, but it seems like the goal is to pretty much get the minimum number. And the minimum score we can get is the maximum number minus the smallest number. It seems like the best way to go would be to get all the maximum numbers. Well, there's no way to tell what number is a max number and what number is not a max number. It feels like the wave would be to get all the numbers closer to the median point. The closer the numbers, maybe there's a greedy solution here. The closer all the numbers are to one another, the smaller the min could be. The question is, how do we get them all to be the same value? I think the value we should try to get them all to is the maximum value minus the largest value in k. Right? Because if we take 6, if we took 6 and we subtracted k from it, the smallest we can make 6 is 3. So we should try and get all the values as close as we can to 3, or to 3 itself. They end up making them all to be 4, but that's fine. So what we can do is figure out largest num. We don't have to sort it. We don't have to sort it because we can get the max number in linear time. So we just assume largest num is equal to 0. We'll do const num of nums, right? And we'll say largest num is equal to the max of largest num and num. Now we have the largest number. The goal number is going to be largest num, right, minus k. So let's just say the largest number is -0 and k is 3. We would have -3. Similarly, if the value was if the largest value was -3, the largest value could be -3 minus 3, which would actually give us 0, which is perfect. So the goal number is always going to be, the goal average is going to be largest num minus k. From there, we can iterate through every number in nums, and the goal is going to be to get it as close as we can to that middle value, right? So what we can do is say, if nums sub I, right, minus k, so if we can subtract k, right, and the number would be less than or equal to goal, then we'll set num sub I equal to goal. So if we go past it or equal to it, right, then it means we have that we shouldn't. Otherwise, yeah, well, we should do the opposite too. Num sub I plus k is greater than or equal to goal, then it should also equal goal. So let's just say we're trying to get to three, like an example 3. We could do 1 plus 3 and get 4, or we can just go to 3. So we should just go to 3. Right? Otherwise, we should make num sub I equal to the shortest distance between two values, right? So it should be the math.min. Actually, we need to calculate the distance, right? Num sub I plus k minus goal is less than absolute value of num sub I minus k plus goal, right? Then whichever one has the shortest distance to goal is what we'd like to do. So we'll say it'll get the value of num sub I plus k, or num sub I minus k. This might not make any sense, so let's see if this makes any sense at all. So we passed 2 cases, we failed this case right here. Maximum number is 10. We automatically assume that the goal number is subtracting 2. So 10 minus k would give you 8. And we say if 0 minus k is less than or equal to goal, wait, this is off. 0 is already less than 8, so we can't make it equal to 8. That doesn't make any sense. It should be if num sub I is already less than the goal, already less than goal, less than or equal to goal, right? And num sub I plus k would make you greater than or equal to goal, then it should be equal to goal. Then in here we can do the same. We'll say if num sub I is greater than or equal to goal, right? And num sub I minus k will be less than or equal to goal, then set it equal to goal. Now my output is 10. So 0 is less than or equal. Zero is less than or equal to 8. And 0 plus 2 does not make you greater than or equal to goal. But if 0 is greater than or equal to 2 and 0 minus 2 then we're going to say if you do 0 plus 2, which is 2, minus goal, which is 8, we get 6. And then if we do 0 minus 2, which is negative 2. Wait a second, this is messed up. It'd be minus goal. Nice. Yeah, this is not the... Yeah, this was actually kind of a cool problem. Now I'm not so certain why it had so many dislikes. But that was cool. So... let me refresh this page and see if we can find another one to do. So... this is a very, very long problem. Return the number of permutations of 1 to n. Return the number of permutations of 1 to n so that prime numbers are at prime indices, 1 indexed. We call that an integer as prime if and only if it is greater than 1 and cannot be written as a product of two positive integers both smaller than it. Oof. This done seems impossible. Let's see, count. The school cafeteria offers circular and square sandwiches at lunch break referred to by numbers 0 and 1, respectively. All students stand in a queue. Each student either prefers square or circular sandwiches. The number of sandwiches in the cafeteria is equal to the number of students. So you have two parallel arrays. The sandwiches are placed in a stack. At each step, if the student at the front of the queue prefers sandwich at the top of the stack, they will take it and leave the queue. Otherwise, they will leave it and go to the queue's end. This continues until none of the queue students want to take the top sandwich and are thus unable to eat. Okay, so if the student prefers a sandwich, they take it. If they don't, they go to the end of the queue. You are given two integer arrays, students and sandwiches, where sandwiches survive as the type of the ith student. No, sandwiches survive as the type of the ith sandwich in the stack. I equals 0 is the top of the stack, and student sub j is the preference of the jth student in the initial queue. J is the front of the queue, and 0 is the top of the stack. Return the number of students that are unable to eat. This seems like a simulation problem, and then what we can do to make sure we can tell whether or not a student can eat or not, we can use like kind of like a I forgot what they call it, but kind of like a circular linked list sort of thing, where if the two pointers match up, if the skip pointer matches up. Pretty much if a student skips twice, if any student skips twice, yeah, if a student skips twice, then we know that the number of students remaining in the queue cannot eat. So we have 2 students preferring squares and 2 students preferring circulars, right? 0 does not match 1. So we push this to the end, right? 1 doesn't match this one. So then 0 takes it, right? 0 doesn't match. Then we take 1, 0, 1, and all the students can eat. Another thing I'm realizing is that we can just check matching here. We don't have to do a simulation. If we have 3 1s, right, and we have 3 1s here, but we have 4 total 1s. It seems like we can just count the number of 1s and 0s in both. If we count the number of 1s and 0s in students, and we can do student minus the sandwiches, but we have 4 students, right? For 4 1s, which means we have 1 square sandwich left over, and we only have 2. We have 3 minus 2. My bad. We have 2 sandwiches, right, and 4 students, which means we have 4 minus 2, which gives us 2 students preferring square sandwiches. And we have 3 minus 1, leaving us 1 student. So I think we can do this in linear time. So we'll say const student 1s equals students dot filter we'll duplicate this and we'll say student 0s. Duplicate this 2 more times. We'll say circular sandies and I forgot to add to all of these we should just be able to return student 1s. So if we have 4 students who need sandwiches, right, and we have 16, if we have, let me change this to square students, circular students, right? If we have 5 square students, we have 5 square students and we have 10 circular sandwiches. All the students got to eat. We'll say square students remaining will be equal to square students minus square sandies. And now that I'm thinking about it, right, if the answer is less than 0, we'll make it 0. Otherwise, we'll do square students minus square sandies. Similarly, we'll say circular students remaining circular students minus circular sandies equals circular students minus circular sandies. And hopefully this works. I output 1. I said 4 students minus 2 or minus 3 sandwiches leaves you 1 remaining, and then I have 2 circular students minus 2 sandwiches. Yeah, we should return the number of students that weren't able to eat. They're saying there are 3 students that weren't able to eat, which doesn't make any sense to me. I think I got these wrong. The circular sandies So we have four square students, which is true. 2 circular students. How many sandwiches? We have 3 square sandwiches and 3 circular ones. So how do we not get the correct answer here? We're doing 4 minus 3, which means we have 1 student remaining. And we're doing 2 minus 3. Yeah, it's unclear why the answer is even equal to 3 here. So, yeah, I don't understand. If you why do we have to respect the order of the queue if a student only takes the sandwich they prefer? Well, I think we'll stop there for today.